Let's spend a few minutes finishing up talking about systems of equations word problems and how we build the equations and then solve them using elimination or substitution. Yesterday we finished up the van and bus problem and discovered that there were 8 students per van and 22 students per bus. Today we'll continue with a slightly different kind of word problem. Take a moment and read this problem. For those of you who can't see the screen, here's what it says. The Turpentine Creek Animal Shelter rescues both big cats, such as tigers, lions, and more, and exotic birds, for example, peacocks, parrots, other things like that. As of today, the Turpentine Creek shelters 10 different animals. Some of these are big cats, and some of these are birds. In all, there are 36 legs. How many cats and how many birds is Turpentine Creek sheltering? This problem is a little different than the previous ones. In your previous examples, you've been given a paragraph where a single sentence gives you the new equations. In this case, we don't have that specific sentence. So let's start by analyzing what we do know. The first thing to think about is, what exactly are we actually looking for? Based on the last sentence here, we know that what we're actually trying to find is how many cats and how many birds are at the shelter. So let's think about variables. Since we're looking for the number of cats and the number of birds, I'm going to use C and B. I'm going to define these as follows. Since we want to know how many cats there are, C will represent the number of big cats. And B will simply represent the number of birds. Once again, I could have used X or Y, or A and B, or Q and S. It doesn't really matter. But in this case, I'm going to choose letters which represent my variables so I don't get mixed up. Next, let's think about what other information the problem definitely gives us. The first sentence simply tells us about the situation, so we can cross it out and ignore it. It doesn't actually affect the mathematics. And we've now answered or used the last sentence, so that sentence doesn't matter anymore. So now we have 3 sentences that we still need to deal with. The first sentence, as of today, Turpentine Creek shelters 10 animals. The second sentence, some of these are big cats, some are birds. And the last sentence, that in all, there are 36 legs. Let's examine the first sentence. As of today, Turpentine Creek shelters 10 animals. That means that if you think about it, the entire center has a total of 10 animals. So our question becomes, what equation will give us this total of 10? If we think about the fact that C represents the number of big cats at the shelter and B represents the number of birds, we can come back and realize that the number of cats added to the number of birds will equal 10. There we go. We've used up this line. Next, let's look at the last one. In all, there are 36 legs. This is by far the hardest thing to conceptually grasp. Just like before when we realized that there were a total of 10 animals at the shelter, we now know that there is a total of 36 legs. So something has to equal 36. We can also make the assumption that it has something to do with cats and birds, and we're probably adding them together. The question is, how can C plus B equal 10 and C plus B equal 36? Well, think about what you're measuring. In the first equation, you're measuring the number of animals. In the second equation, we're not measuring the number of animals anymore. We're measuring the number of legs. So, as you think about it, how many legs does a big cat have? Hopefully you recognize that the answer is 4. Same thing for birds. How many legs does a bird have? 2. When you multiply the number of legs times the number of cats, you get the total number of legs for cats. When you multiply the number of legs times the number of birds, you get the number of legs for birds. When you add those together, you get the total number of legs. So here we have our 2 equations. Let's solve them real quick. For this problem, I'm going to use substitution. This is simply because I can look at this equation and see that I can solve it very easily for either C or B. So let's do that. C plus B equals 10, and I've decided that I want to solve it for the variable C. So I'll subtract B from both sides, and I get a new equation that says C is equal to 10 minus B. Once again, we'll take this, we'll cut it out, and we're going to use this to replace the C up here. So my newest equation becomes 4 times 10 minus B plus 2B equals 36. Once again, at this point, we've eliminated the variable C, so we can solve. Let's keep going. We'll distribute our 4 and get 40 minus 4B plus 2B equals 36. Combining our like terms of 4 and 2B will give us the line 40 minus 2B equals 36. We'll subtract 40 from both sides and get a new line of negative 2B is equal to negative 4. Because 36 minus 40 gives us negative 4. Finally, we'll go ahead and we'll divide. In this case, we're dividing by negative 2. Our final answer becomes B is equal to positive 2. It's a good thing to think about what makes sense. If we'd gotten a negative number here, we know we would have made a mistake because the number of birds can't be negative. You can't have a negative amount of birds. Let's finish up by finding the number of cats. Since we know that B is equal to 2 and B plus C equals 10, then we can go ahead and simply take our 2 and plug it in. So 2 plus C equals 10. We'll subtract 2 from each side and get that C is equal to 8. So once again, putting this in context, we know that the number of birds at the shelter is 2, and the number of cats at the shelter is 8. Remember, when we're working with word problems, we're always going to put our answer in context. We don't have to put it as a XY coordinate pair because we actually have information. Because we know exactly what each of these are, we can simply define the answer as being the number of birds is 2 and the number of cats is 8. We don't have to worry about a coordinate pair. Let's move on and look at one last sample problem. In this Etsy problem, you have opened an Etsy shop selling genuine fake dog poop and authentic imitation whoopee cushions. It costs you $1.70 to buy the supplies to make the fake dog poop and $1.30 for the supplies to make an imitation whoopee cushion. In the Etsy store, you're going to sell the dog poop for $5.60 and the whoopee cushions for $5.40. Let's say that last month you spent $37.90 on materials and sold $147.20 in finished products. And the question we're really asking is, what items did you sell? Just like the last problem, let's start off by defining our variables. The two things we don't know is how many of each item we sold. And in this case, we're selling whoopee cushions and fake dog poop. So I'm going to use the variables P and W. when we choose how we're defining it, since we're looking for how many of each we sold, we'll define P as the number of fake dog poops sold, and W as the number of whoopee cushions sold. The number of whoopee cushions sold. There, we've used up the last line. As we go through this and start removing lines that don't matter, we can start by eliminating the first line. It doesn't matter what we're selling, whether it's fake dog poop and whoopee cushions, Cokes and Pepsis, or just any other widget that you want to sell, it doesn't affect the math. So the really important parts are going to be here. This first sentence tells you how much it costs you to build one. The second sentence tells you how much you sell them for. As you read the problem, hopefully you'll notice that this first sentence, highlighted in blue, is going to tie into the materials cost in the second problem. And this second sentence, circled in green, will tie into our finished product price. And we can use these to build our new equations. So let's do that. From the word problem, we know that we sold a certain number of dog poops and a certain number of whoopee cushions in both situations. In the first one, we're looking at how much it cost us to make them. We saw in the first problem that we spent $37.90 on materials, so we'll put that in. We saw in the second problem, where we're selling them, that we made a grand total of $147.20. So we'll add that in. Now we need to figure out what our coefficients are that belong in front of each of our variables. So let's think about that. Our first problem is measuring materials cost. If we come back to the problem, we notice that it's $1.70 to buy the supplies for the fake dog poop and $1.30 for the whoopee cushions. We can take these and attach them to our variables. In this case, our fake dog poop costs us $1.70 to make, and our whoopee cushions cost us $1.30. In our second equation, we're going to be looking at how much we sell them for. You'll see that in this sentence, we sell the fake dog poop for $5.60 and the whoopee cushions for $5.40. We can take this back and add it to our equation. So $5.60 and $5.40. So now we've used all of the information out of our problem to build two equations. So we have our system. So let's look at how we can solve it. Here's our system written out. I'm going to use elimination because I don't see an easy way to solve this for a single variable. When we're looking for elimination, we'll start with step 1, aligning the variables. As we can see, our variables are already aligned, as are our constants and our equal sign. So we don't have to worry about step 1. It's already been done for us. Let's move on to step 2, where we'd make one of the coefficients equal to the other. Looking at this problem, I don't see an easy way to turn $1.70 into $5.60 or $1.30 into $5.40. There's not an obvious solution. It's not like we have 2 and 4 and we simply multiply the top by 2 to make them both into 4s. That's simply not going to work in this case. So we're going to do something a little differently. Instead of looking for a single number where they have the least common multiple, we'll jump straight to multiplying by the other value. In this case, I've decided that I'm going to eliminate the D variable. So I'm going to multiply the first value by 5.6 and the second value by 1.7. You'll notice what I'm doing is I'm multiplying by the opposite value of D. This guarantees that the result will actually create an equal number, because we know that if you multiply something by the other, it will always be the same value. So let's see what happens. When we multiply 5.6 times each of our upper values, we get 9.52D plus 7.28W is equal to 212.24. Remember, this last column is measuring dollars. When we multiply 1.7 times the second line, we'll end up with $9.52D plus 9.18W equal to 250.24. So, by multiplying by the opposite values, we've created the same coefficient on the D variable. To get rid of D, we'll subtract one from the other. 9.52D minus 9.52D will give us 0. 7.28W minus 9.18W will give us negative 1.90W. And 212.24 minus 250.24 will give us negative 38. We can continue on to solve by dividing. We'll divide each side by negative 1.90 and discover that for our whoopee cushions, we've made exactly 20. So remember, put this back in context. What is W measuring? W is measuring the number of whoopee cushions sold. So this 20 is saying that we sold 20 whoopee cushions during that month. Let's figure out how many fake dog poop we sold. Since W is equal to 20, we just need to plug it back into any of our values. In this case, I'll plug it into our first equation. So 1.7x plus 1.3y is equal to 3790. If we plug our W value, well, what mistake have I made? We're actually looking at D's and W's, not X's and Y's. So if we take our W value, plug it back in for W, we can go ahead and figure out what's happening here. 1.7 times D plus 1.3 times 20 equals 3790. So 1.7D plus 26 is equal to 3790. We'll subtract 26 from both sides. 1.7D is equal to 3790 minus 26, or 1190. Divide both sides by 1.7, and we get that the number of fake dog poops that we made was 7. So once again, we'll put this in context and recognize that we sold 20 cushions and 7 dog poops. Again, since it is a word problem, we're really looking at what does these numbers mean, not a single coordinate pair. To finish up today, we'll continue doing some practice problems. You're going to receive a sheet of word problems that I'd like you to begin working. In your notebook, on the next blank left page, which should be page 17, I want you to begin completing these practice problems. As you work them, make sure that you write out and define your variables. Every single problem should have your variables defined and written out. Other than that, it doesn't matter how you solve them, whether you use substitution, elimination, or even graphing. but make sure that you explain your reasoning when necessary. And in the end, when you answer the problem, use it in terms of the question. If it's a word problem, you should be giving me an explanation, not just a coordinate pair. The sheets you're getting is a class set, so please do not write on these sheets. They need to be turned in at the end of the period.